You can reduce every statement in physics to statements that involve either no dimensions or mixtures or sets of these five. That's it. So the goal here is to try to put together a story that accounts for all the actual measurements we've made through our whole history of physics, right, or a whole history of humans so far, to identify the built-in features that are fixed into reality. So that's very clearly statements here. We are assuming the constants of nature are accurate measurements of built-in features allowed in physics. Okay, so we're taking that as the starting position. And now what we're trying to do is we're trying to come up with any sort of logical model, a geometric-based structure. It has to have explicitly specified logic. And we want to find the simplest possible logical model that contains and explains all of those features. Okay, if that simplest model has other features, cool. Whatever happens, the simplest one that can contain the features we know are real. we need to, at minimum, account for all of those. But by account, we really mean deeply. You can't just account for something by just reproducing it. That reproduction needs to be some sort of action, some sort of story, some sort of insight to the structure of what's going on, not just, you got it right. That's what quantum mechanics does, right? It gets it right, in a way, like statistically. But it didn't really give you insight to the structure of what was getting it right. So we're trying to get past that. And we're not starting out with an intuition of exactly what the universe is supposed to be. I mean, we've all done that. I've done that. I wrote a whole book to try to fine-tune my intuition of what it must be and fine-tune my collection of the details I have to keep track of and account for. Okay, but at the end of that book, I ran into a wall. The main thing I tried to focus on was trying to visually, or without reducing dimensions, track the action of gravity, right? That we have exact equations from general relativity for what gravity is. And I wanted to not have to take a slice and then understand those equations a slice at a time. I wanted to find some way to more richly understand them. And the method for doing that was to introduce a notion in which space-time itself, the metric itself by which everything is being compared, is actually quantized, so that there are other degrees of freedom that allow the metric to mix, right? There's a whole bunch of bubbles that can move around, but it gives you available density gradients and all the fluid actions that we characterize in fluid mechanics. Okay, the problem was that although this separation of the metric itself gave us density gradients, which actually perfectly map to the logic of warped spacetime, they didn't give us an explanation in the end. Once we were mapping spacetime's warping curvature, that mapping didn't then give us a next step of insight that said, and now I know why the boundaries we made up or imposed on the situation in order to have that kind of structure exist. You follow me? So we got to a position where we found if we come up with a condition where we impose this different kind of metric of space-time, one that's quantized and has parts that can all mix about and so on, then we can reproduce the same sort of effect. But the goal when you have a model like that, when you have so much you're just assuming, is that you don't really believe the model until you kind of tweak it to make the fit that you were looking for. But that tweaking and that fitting should then automatically be fit to a whole bunch of other parameters you weren't actually trying to tweak it to. So that's the situation I ended up in. It didn't give me any insights for how quantum mechanics would be coming out of the same sort of model. And more damningly, for me, logically, is that once we got to the end where we could actually explain general relativity in terms of that same different sense of metric, that explanation didn't extend naturally in any way that I could see to the effects of quantum mechanics. So it was just fine-tuned. It wasn't powerfully revealing. So what we're going to do is instead, we're going to back up and not assume whatever model you're currently assuming, what the space is infinite, or that it's spherical and infinite or finite, or cubic and infinite or finite. Those are common visions. We're not going to assume a certain geometry. What we're trying to do is focus on the measured transforms, or the measured built-in facts of reality, and find some way to make sense of them. So first step is to list them, or to become aware of them. So the physics track go through beginning to high-end courses is it tunes you into the investigation humans have had so far using measurements to look into reality in new ways. Look into reality in ways beyond what you can do just with your hands and your eyes, using tools to look further into the structure and precision of what's going on. Okay, so in that process, people have discovered that they can model actions using equations, and some of those equations, most of those equations, have strange scaling factors that relate things to each other, different parameters like as time or length and space, right, to each other, but with huge scalings. So it's not a one-to-one conversion, but there's a conversion. Okay, so the first thing to notice is that there are conversions between the different parameters of reality. So I guess even before that, 5 dimensions right, than just what the shape of reality is. But we have 5 different bases, different actions by which we can make a reference in this story already. So that's a starting position. Those measures, times, time, space or length, charge, temperature, and mass. All right, this is very, very fast, but the major point here is that these 5 bases, these 5 dimensions, form a network of logic that account for all the transforms and exchanges we've found or just seen so far in physics. The things we're trying to account for. We're not trying to account for ones we haven't seen yet. Okay, so all of them, that's a really amazing thing. You can reduce every statement in physics to statements that involve either no dimensions or mixtures or sets of these 5. That's it, okay? So there's 5 ways to make unique measurement in the world, or 5 unique dimensions.